Welcome to today's paper reading. Today's paper is titled, LongRAG, Enhancing Retrieval-Augmented Generation with Long Context LLMs. This paper was published on the AR14 preprint by Ziyan Jiang and colleagues from the University of Waterloo. In the traditional RAG framework, retrieval units are typically short, often consisting of 100-word Wikipedia paragraphs. This design requires the retriever to search through a vast corpus, leading to inefficiencies. The imbalance between the heavy retriever and light reader can result in suboptimal performance due to the loss of contextual information in these short units. To address this, the authors propose LongRAG, a new framework that uses longer retrieval units. LongRAG processes the entire Wikipedia corpus into 4K token units, which are 30 times longer than the traditional units. This reduction in the number of units from 22 million to 600,000 significantly lightens the retriever's load, enhancing retrieval performance with fewer top units. This approach also minimizes the likelihood of retrieving hard negatives while preserving the semantic integrity of each unit. The Retrieval-Augmented Generation (RAG) framework has been used to enhance large language models by incorporating external knowledge. Traditionally, this framework uses short retrieval units, such as 100-word passages, which require the retriever to skim through a large corpus. This design places significant pressure on the retriever, necessitating the recall of many units and additional re-ranking. In contrast, the LongRAG framework introduces long retrieval units, which can be entire documents or groups of related documents, containing over 4,000 tokens. This design simplifies the retriever's task and leverages the capabilities of long-context language models. The LongRAG framework has demonstrated improved performance in open-domain question-answering tasks, achieving results comparable to the strongest RAG models and showing generalizability across different datasets. Figure 1 contrasts the traditional RAG framework with the LongRAG framework in terms of retrieval unit length and performance. Traditional RAG operates on short retrieval units, necessitating a retriever to scan a vast number of units to locate relevant information. In contrast, LongRAG employs long retrieval units, which are 30 times longer, significantly easing the retriever's burden and enhancing retrieval quality with fewer top units. This approach leverages long-context language models to achieve superior performance. The lower part of the figure compares the QA performance of various methods on the NQ and Hotpot QA datasets, highlighting LongRAG's advantages. The LongRAG framework consists of two main components, the long retriever and the long reader. Unlike traditional RAG, which uses numerous short retrieval units, LongRAG focuses on long retrieval units, typically fewer than 10, to be processed by the reader. The long retriever is designed to prioritize recall with coarse granularity, shifting the burden of extracting exact answers to the reader. This involves 3 steps: formulating long retrieval units, performing similarity search, and aggregating the retrieval results. The long reader, on the other hand, feeds the long retrieval results into a large language model to reason over the context and generate the final output. This component must be capable of handling long contexts without position bias, and effective strategies are employed for both short and long contexts to optimize performance. Figure 2 illustrates an example of the LongRAG framework, which forms long retrieval units of at least 4K tokens by either using entire documents or grouping related documents. This example shows how multiple Wikipedia documents are grouped through hyperlinks, enabling multi-hop question answering from Hotpot QA with fewer retrieval units. Compared to traditional RAG, LongRAG significantly reduces the likelihood of retrieving hard negatives during the retrieval stage and effectively leverages recent advancements in long-context language models. In this section, we detail the experiments conducted to evaluate our proposed methods. We tested our methods on 4 question-answering datasets: Natural Questions, NQ, Hotpot QA, Casper, and Multi-Field QAN. These datasets vary in average document length, ranging from 130 to 6.9K tokens. We assessed retrieval performance using answer recall, AR, and recall, R, metrics, demonstrating that using long retrieval units, 4 to 8, can achieve comparable performance to using hundreds of short units. Finally, we evaluated full question answering performance using exact match, EM, and F1 scores, showing that our LongRAG framework outperforms traditional RAG when using long retrieval units. Table 1 provides an overview of the 4 datasets used in our experiments. The corpus source column indicates the origin of the retrieval corpus. NQ and HotPotQA are sourced from Wikipedia, Casper from scientific documents, and Multifield QAN from multifield documents. The 2 Wikipedia-based datasets use a massive retrieval corpus containing millions of short documents, while the other 2 datasets use a smaller corpus consisting of hundreds of long documents. Table 2 demonstrates the retrieval performance on the NQ dataset using a long context retriever. This approach significantly compresses the corpus size from 22 million to 600,000 units, resulting in a 20-point increase in top 1 answer recall from 52.24% to 71.69%. Additionally, the long context retriever requires 10 times fewer retrieval units to achieve comparable performance, thereby reducing the burden on the retriever. Table 3 presents the retrieval performance on the HotPotQA dataset, highlighting the benefits of using long context retrieval units such as documents and group documents. This approach significantly reduces the corpus size by approximately 30 times, from 22 million to 600,000 units, and improves the top 1 answer recall by about 20 points, from 52.24% to 71.69%. Additionally, it provides more comprehensive information compared to shorter passage-level retrievals, which might suffer from incomplete information due to chunking. The table also notes that in HotPotQA, retrieval units are only at the document and group document levels, as the dataset uses abstract paragraphs from Wikipedia pages. Table 4 compares different methods for encoding long retrieval units in the context of long retriever systems. The table highlights that using a general embedding model like BG large NV 1.5 and approximating the similarity scores between the query and chunks within the retrieval unit outperforms using a long embedding model like E5 Mistral 7B to encode the entire long context directly. This approach is more effective and suggests that future advancements in long embedding models could further improve the framework. Table 5 presents the QA results on the NQ test dataset and HotPotQA dev set, comparing LongRAG with 3 groups of baselines: closed book, fully supervised RAG, and no fine-tuning RAG. On the NQ dataset, LongRAG achieves an exact match rate of 62.7, comparable to the strongest fine-tuned RAG model like Atlas. On the HotPotQA dataset, LongRAG achieves an exact match rate of 64.3, close to the state-of-the-art fully supervised RAG frameworks. Table 6 illustrates the performance of LongRAG and traditional RAG on non-Wikipedia-based datasets, Casper and Multifield QAN. The evaluation metric used is token level F1. The datasets consist of long documents, averaging at least 4K tokens. The table shows that LongRAG, which processes long retrieval units, achieves superior performance compared to traditional RAG, which processes short retrieval units. Specifically, on the Casper dataset, LongRAG achieves a 26.3% F1 score with a single 5K token retrieval unit, outperforming the 22.6% F1 score with 100 short 200 token retrieval units. Similarly, on the Multifield QAN dataset, LongRAG achieves a 57.5% F1 score with 5 7K token retrieval units, surpassing the 51.3% F1 score with 100 short 200 token retrieval units. Figure 3 compares various settings of LongRAG using 200 test cases from the test set. The upper part shows the NQ dataset, and the lower part shows the HotPotQA dataset. On the left, it illustrates how overall performance changes with different retrieval unit sizes and the number of units fed into the reader. On the right, it shows that end performance does not increase monotonically with the recall score, and LongRAG is more robust to the influence of hard negatives as the context length of the reader increases. Figure 4 presents a comparison of 6 different readers within the LongRAG framework on the NQ dataset, using 200 test cases. The readers evaluated are Gemini 1.5 Pro, GPT-4 Turbo, GPT-4o, Claude 3 Opus, Claude 3.5 Sonnet, and DeepSeek V2 Chat. The results indicate that GPT-4o performs the best, achieving the highest exact match score. This suggests that GPT-4o is the most effective in processing and comprehending lengthy contexts within the LongRAG framework. The performance of the other readers, such as Gemini 1.5 Pro and Claude models, is also highlighted, showing their effectiveness as readers. However, DeepSeek V2 Chat, an open-source LLM, shows significant performance degradation compared to the black box LLMs, indicating the framework's dependence on the long context understanding ability of LLMs. In the related work section, the focus is on three main areas: retrieval-augmented generation, long context large language models, and long context embedding. For retrieval-augmented generation, the predominant architecture is the retriever reader style, with recent efforts aimed at improving both the retriever and the reader components. The impact of document granularity on the retrieval process is still an underexplored area. Regarding long context large language models, the challenge lies in the quadratic increase in computational cost with sequence length. Strategies like flash attention and various position encodings have been proposed to mitigate this issue. Lastly, in long context embedding, recent developments have extended the context length for embedding models, either through pre-training or by utilizing existing large language models. Methods to extend the content window of embedding models have also been explored. In this paper, the authors introduced the LongRAG framework, a novel approach designed to address the imbalance in retrieval tasks. The framework is composed of two main components, a long retriever and a long reader, both operating on 4K token retrieval units. This design significantly reduces the corpus size, allowing for strong retrieval recall with minimal noise from hard negatives. Additionally, it preserves the semantic integrity of each document. The framework was tested on 4 end-to-end question-answering tasks, demonstrating superior performance without the need for additional training. The authors believe that LongRAG can serve as a foundation for future RAG system designs. Thank you for watching.